The tip of each prong of a tuning fork, emitting a note of 320 Hz, vibrates in simple harmonic motion with an amplitude of 0.5 millimeters. What is the speed of each tip when the displacement is 0? So let's write down what we have, what we want to work out. We want to work out speed. We know the displacement is 0. We have the frequency of 320 Hz, and we have an amplitude of 0.5 millimeters. So when displacement is 0, the speed is at a maximum value. And if you're not entirely sure why that's the case, let's think of a pendulum. I'll use the example of a pendulum, but the end result will apply to all simple harmonic oscillators. For a pendulum, when it swings to one side, it stops momentarily before it returns back. Kinetic energy is 0, and all of that kinetic energy has been transferred to GPE as the pendulum is now in its highest position. It then swings back to the middle, it loses that GPE, and that GPE gets converted to kinetic energy. This is where kinetic energy is a maximum. It therefore has the most speed, and this is when displacement is 0. So we are trying to work out what Vmax is. Vmax is equal to omega A, that's the equation for max speed. Omega is the same thing as 2 pi f. This is then 2 pi times frequency times amplitude, which I'll leave in millimeters because we want to have our final unit in millimeters per second. If I multiply all of those numbers except for the pi, I end up with 320 times pi, which is d.